Hi, welcome to the heat, temperature, phase changes, and thermodynamics module. This is a really big pile of information. Um, and there's quite a lot of reading that you're going to do for this module. Um, so the first thing that you actually get introduced to is the notion of temperature and some scales to report the temperature, right? Units. In the United States, degrees Fahrenheit is what people tend to use when they describe the weather or the temperature to bake a cake at. But there is a slightly more scientific, it's an SI unit of temperature and temperature change called the degrees Celsius. But there is a third temperature scale referred to as the Kelvin scale. And it's important to sort of have some knowledge about the relationship between the three scales. Kelvin is particularly scientific because 0 Kelvin is special, right? That's the lowest, or there is no such thing as a lower temperature in nature, right? There's not a negative Kelvin temperature that's possible. Okay, so you tend in this module you'll start off by learning about these temperature scales, and you'll also learn about a related but not identical term referred to as the heat. And heat flow represents energy flow for what are called spontaneous processes. These are the processes that nature just does, right? So these would be the processes that would happen on average before humans and everywhere in the universe without humans in it, and also in processes where humans are around. But humans have been able to develop certain machines that seem to do non-spontaneous things. For example, a refrigerator is an example of a non-spontaneous heat flow. Refrigeration is what I meant to, refrigeration, right? Like air conditioners and refrigerators in kitchens, right? So heat flow and the definition of heat is an important concept in this module. Also, like what does temperature physically represent about a material? That gets introduced as well. And while you're being introduced to how the temperature of material represents something physical about the material, you'll study the relationship between temperature and heat with a concept called the specific heat capacity, as well as what are known as the heats of transformation. For example, the heat of melting or the heat of condensation. These are known as heats of transformation. And all of these topics, what they do is they help us understand, for example, refrigerators, but they also help us understand the physics of weather, right? And weather forecasting, that is weather prediction. So a final chapter in this list of topics is associated with what are called the laws of thermodynamics. And the laws of thermodynamics are essentially just a sort of final summarization of the fundamental topics in all of the stuff that you learn along the way, including the importance of temperature. It just identifies temperature as a fundamental quantity and how it is used. It also identifies that energy conservation, when heat and work are equivalent, it's sort of equivalent ways of changing the energy of a system. That is a law of thermodynamics. And then there is also a term. It's a new term. It looks like the word energy, but it's not energy. This term is called entropy. And entropy is very interesting, and lots of poems and literature and science fiction is written surrounding this term. But entropy is a very real physical quantity that represents disorder, right? It's a physics of disorder. It is the subject of an interesting law of thermodynamics. So please go and read for what happens to the entropy as time goes forwards into the future in nature. Okay, I hope you enjoy the topics in this chapter. I'll end by saying that these topics are the most human connected topics. In some sense, these topics, they represent sort of a human's interaction with nature. Feeling words like temperature, right, and heat, right? Another word that may get mentioned is pressure. I'd argue that these would be the first things that a human would identify as important, sort of to pay attention to, like whether or not all of the water outside is frozen or is it liquid, right? So that's a sort of a phase difference notion. And then is it warm or cold outside? When they touch something in a fire, do they get burnt by it, If you're paying attention to weather, you might notice pressure changes happening when high pressure or low pressure moves into an area, and how that's related to weather, whether or not it's going to be windy, whether or not there's going to be moisture or rain. Yeah, so these are very human topics. Also, there is some very early engineering based on these topics. For example, motors, especially the gasoline or diesel type motors. These are based on the internal combustion engine. And there's lots of heat and lots of pressure to push on pistons, right, to cause a person to be able to develop an engine or a gasoline motor that does something for people. Yeah. Okay. Please enjoy the material.